This video from Math Bay about coordinate values on the unit circle. We're going to do this in two parts. The first part is going to be just working with the 30, 60, and 90 degree angles between 0 and 90. And then the second part will deal with reference angles and angles from 0 to 360. So what we're going to start with now, we're going to use trigonometric ratios and special right triangles to develop coordinate values on the unit circle in terms of sine and cosine. This will lead to trig values for angles which are not acute. Let's begin with acute angles associated with our special right triangles. That's the 30, 60, 90 and the 45, 45, 90. First, we're going to look at when you go from 0 in the positive direction, a 30 degree angle. We'll also look at what happens when you go a 60 degree angle from 0 in the positive direction. And we'll also look at a 45 degree angle. All right, so let's get started. For 30 degrees, which is pi over 6 radians, we're going to look at the x and y coordinates for the reference triangle created. If I take that 30 degree angle, I drop an altitude and turn it into a 30, 60, 90 triangle. Because we are on a unit circle, the radius is 1, which means the short leg is half of the hypotenuse, which is 1/2, and the long leg would be the length of the short leg times the square root of 3, which is going to be square root of 3 over 2. So that's the length of the long leg on this 30, 60, 90 triangle. So this is going to be square root of 3 over 2. Okay, because we're in quadrant 1, both the x-coordinate and the y-coordinate are positive. So our values of x and y for this triangle are positive square root of 3 over 2 and positive 1/2. Now let's look at what the sine, cosine, and tangent value are for this angle of 30 degrees. The sine value would be opposite over hypotenuse, and since the opposite is 1/2 and the hypotenuse is 1, 1/2 divided by 1 will give us a value of sine, which is 1/2, which happens to be equal to the y-coordinate. The cosine value is adjacent over hypotenuse. Square root of 3 over 2 divided by 1 is going to be square root of 3 over 2. Which happens to be equal to the x-coordinate. The tangent value of this angle will be the length of the opposite of the angle over the adjacent to the angle. So we're doing 1/2 divided by square root of 3 over 2. We take the reciprocal and multiply. We get 2 over 2 square root of 3. The 2's cancel. We get 1 over square root of 3. That is the tangent. If we rationalize that denominator by multiplying by square root of 3 over square root of 3, we get square root of 3 over 3 as the value of the tangent, depending on whether or not you're required to rationalize your denominators. So those are all the essential values for a reference angle of 30 degrees. Let's look at 60, which is going to be quite similar. On my unit circle with a radius of 1, if I drop an altitude, this is the same right triangle as this one. It's just been reversed with the 60 degree angle at the origin rather than the 30. So the short leg is going to be 1/2. The long leg is going to be square root of 3 over 2, which means the x coordinate is 1/2 and the y coordinate is square root of 3 over 2. The sine of 60 is opposite over hypotenuse, so that's going to be square root of 3 over 2 over 1, which is going to be square root of 3 over 2. The cosine is going to be the adjacent over the hypotenuse, so we're taking 1/2, dividing it by 1, and getting 1/2. And the tangent will be the opposite, square root of 3 over 2, over the adjacent, 1/2. I take the reciprocal and multiply and simplify, and I get just square root of 3 for the tangent. And finally, we're going to look at our 45 degree reference angle. So if I drop my altitude and look at my unit circle with a radius 1, to get the length of the legs on a 45, 45, 90 triangle, I have to take the length of the hypotenuse, which is 1, and divide it by square root of 2. Rationalizing that will give me 1 root of 2 over 2, or just square root of 2 over 2 for the lengths of the legs on the right triangle. So this is square root of 2 over 2, and this is square root of 2 over 2, making the x and y coordinate both square root of 2 over 2. When I calculate the sine of this 45-degree angle, it is opposite over hypotenuse. And since the hypotenuse is 1, we're dividing by 1. That's the sine, square root of 2 over 2. The cosine is the adjacent over the hypotenuse, which is also square root of 2 over 2 over 1, which is square root of 2 over 2. And the tangent is opposite over adjacent, and since they're equal, the tangent is 1. So if we look at these values and make some conclusions based on the data, we should be able to pick out a pattern of the fact that the x coordinate is always going to be the cosine of the angle. These two columns are the same. And the y coordinate is always the sine of the angle. These two columns are the same. So an xy point becomes cosine theta sine theta if we look at the terminal point on the circle for the angle which we're finding the reference angle of. So for 30 degrees, the coordinates of square root of 3 over 2 and 1/2 are actually the values of cosine theta and sine theta. So all the points on the unit circle become the actual trigonometric values for the angle, which is situated at the origin. We call this a reference angle, and a reference angle always is situated at the origin, starts from 0 as you travel around in a counterclockwise direction. So the coordinates of the point will always be the cosine and the sine. Now for the tangent, it's the same as before. We're doing the opposite over the adjacent, or we're doing the y divided by the x, which is the sine divided by the cosine, which we previously proved. So let's look what happens when this is worked on with an angle, which is not exactly a special right triangle value. So for any random angle, we'll say A, the angle will begin with one ray along the positive x-axis, going to 0 degrees, or 0 radians, and a terminal ray intersecting the circle circumference between 0 and 90, or 0 and pi over 2 radians, because 90 degrees is pi over 2 radians. Thus, the values of the x and y coordinates of the intersection are cosine A and sine A, respectively, meaning that the xy coordinate can be found by cosine sine. So let's look at an angle of 23 degrees. Okay, we take our calculator and calculate what the sine and cosine of 23 degrees are. The sine of 23 is 0.3907. .3907. The cosine of 23 is 0.9205. And the tangent of 23, 0.4245. So what that means is if I'm looking at my 23-degree angle and I drop my altitude, working on a unit circle, the distance going across is 0.9205, or cosine, because cosine A, sine A, 0.9205. And the y coordinate is the sine of 23, which is 0.3907. So the coordinates of this point are 0.9205, 0.3907, or cosine 23, sine 23. So at this point, that means we can redefine trigonometric values of an angle to be cosine theta is x, sine theta is y, and tangent of theta is y over x. So now we can actually use this new definition of our trigonometric values to look at angles which are not strictly between 0 and 90 degrees, or 0 and pi over 2, but all around the unit circle from 0 to 360 degrees, or 0 to 2 pi, which is what we will do in the next video.